Welcome to my talk regarding Windows authentication with multiple domains and forests. My name is Stefan Metzmacher. I'm in the Samba team. I'm working for Cernet, working on Samba for more than 15 years now. So I gave a similar talk at Samba XP earlier this year. The important details of Windows authentication. There I described a lot of the basics, which I will skip a bit today. So if you're interested, you can just download the slides from the Samba XP. Today we will cover the relationship between Windows domains, forests, and the trust between the forests. The Netlogon secure channel, the authentication protocols which are used between client and servers, the resulting authorization token, also related to S3U to self, then the difference between selective authentication and forthright authentication, Kerberos features which are new in newer Windows versions, then improvements we did in Samba to implement support for trusted domains as Active Directory domain controller, and then a few further topics which are just mentioned, and I have some links so you can follow the links yourself and read the online descriptions about protocols. So the basic is trust types and direction. So there are two trust types: down level NT4 style trusts, which are also between Active Directory domains and NT4 domains. Mostly not really NT4, but there are some people still running Samba in a mode where just NT4 is offered. And it's still important for these cases. Yes?
Are these R names, or are these Samba names for these things, or are these Windows names for these things?
I think Windows, but it's at least very similar. So
okay, good.
If you Google for it,
that's fine.
You should be able to find it.
Okay, good.
Yes, yeah. Then we have trust directions, inbound and outbound. For me, it's always a bit confusing which is which. So when you think about a domain member that has an outbound trust to the domain, so it's basically the client side end, which is a trusting side, and it trusts the domain. But in my Samba XP talk, there are a lot more details about this stuff. We have trust attributes. Despite the type and the direction, we have things like forest transitive in the middle, that's for cross-forest trusts. Then we have within forest, that is within a larger Active Directory forest. I have a picture of that in a few slides. One interesting thing I will talk about later is the selective auth, the cross-organization bit, which alters the behavior quite a bit, and the others are more or less internal and are just details. So the high-level trust types are workstation domain member trust to the primary domain, external domain trusts. These are non-transitive trusts between either two Active Directory domains or more typically Active Directory domain and an NT4 style domain, or two NT4 style domains. Then we have forest trust. That is the trust between the root domains of two forests. And within the forest we have parent-child trusts, tree root trusts, and for performance optimization shortcut trusts. And again, the Samba XP talk has much more details there. This is a picture of a more complex Active Directory forest. So on the left side we have corp1, that's the tree root domain of the forest. Then we have parent-child domains, the devil domain, product domain. And then what a lot of people don't know about is this, it's possible to have a separate tree in the forest. And then we have the tree root trust between corp1 and corp2, and then the same tree style parent-child domains to support on the right side. And in order to handle forest trust, it's very important to have a summary of all domains and all names which are related to the forest. Then we have, for the example we saw, just two top-level names, corp1.private, corp2.private. Then we have each individual domain with a full qualified domain name of the specific domain and the SID, as well as the short names, which are still used for NT4 style access. Now, the trusts between workstations and also between domains, they use the so-called secure channel for Netlogon. That's basically the trusting domain has a computer konto or interdomain trust konto account, and that is able to talk to the trusted domain in order to verify the authentications. So this is typically used for NTLM authentication, the logon, some logon. There are a few flavors of it. The most modern one is the one with X at the end. That's also used in Winbind. Some Windows versions still use the with flags one, but here it's just a detail, and my Samba XP talk has much more details about the differences. But it's not limited to just NTLMSSP, also Kerberos pack verification. If you have a host that runs multiple services and the service isn't trusted, so like a web server or something like this, it's needed that when the untrusted service connects to the service itself, to the higher privileged services in the OS, that the server needs to verify the pack with the KDC. With normal authentication, it's possible that the receiving service does the verification itself. This is also needed in order to get the forest trust information we saw slide before. So the tree root of one forest just asks the other forest about the details. Then today almost all protocols are able to use SPNIGO. That's a tiny wrapper that allows us to negotiate between Kerberos and NTLMSSP. So it's just the client proposes something, sends an optimistic token, Kerberos in this case here, and then the server either accepts it or says, I just can handle NTLMSSP. And in a trust scenario with Kerberos, we have the situation where the client does all the work, getting credentials and talks to the domain controllers. So first it talks to its own domain controller, the red packets. First the AS request that does the main authentication, and then it gets the service ticket, and the KDC figures out that the principal doesn't belong to the domain, and sends a referral ticket, and then it goes and contacts the other domain's KDC to get the real service ticket, and then the yellow packets do the authentication for SMB in this case. So, yeah. And the authorization data is within the Kerberos ticket, the so-called PAG, and that allows the service to get the authorization data and doesn't have to contact the domain controller itself. With NTLMSSP, the thing is a bit different. There, the client talks to the service. Here, the SMB session setup. There are a few rounds, and then the service contacts its own domain controller, the purple packets, and that domain controller goes on and then connects to the domain controller from the other domain and gets a response and passes that to the service again, and then the server can say yes or no. After this successful authentication, we have, so first we have to authenticate. The client typically provides a full qualified username together with a password. There are also some cases where it's not needed to use the full qualified name, but typically at the domain controller, the full qualified name has arrived. And it's also possible to use smart cards to use Kerberos and authenticate with that. And the result is always either access denied, or we are getting a session key between client and server that can be used to do some integration and privacy protection later on. And the other important thing is that we get the authorization token that is used to evaluate access control later. As I said before, this information is within the Kerberos service ticket and also in the response of the logon Samba on calls. So the authorization token contains things like username, full name, logon domain, various timestamps, when the last logon happens, when the password needs to change, and things like that. And also, the most important thing, the group memberships. And the thing is that the token provided by the trusted domain needs to be expanded with local groups on the trusting side, and needs to do some SID filtering on the trusting side in order to avoid privilege escalations with fake group memberships. There are quite some different rules for that. They depend on the trust attribute values defined for the trust. And it's important that this expanding and filtering happens at each trust boundary, because otherwise it's not possible for the server to figure out the correct token. And that's why it's important that the authentication always gets through the whole chain of trusts. Currently, Samba doesn't do this SID filtering, so that's still to do. So if you have a trust, you need a full trust. So you better be administrator in both domains. in order to make sure that there is no privilege escalation. In Samba we have the so-called auth session infrastructure, which represents the token, and that's the list of SIDs, details about the Windows user, account name on Windows and things like that, and also the Unix attributes like UID and GID lists, which are constructed by the ID mapping in Samba or Winbind, and the Unix username is also there. There are some situations where the service needs to get the authorization token but didn't have the chance to authenticate the client properly. That is, if you have sudo running on a Linux box or something like this, or SSH access with public keys, or also NFS v3 has also the situations where the client is not really authenticated and we still need to find out the group memberships. And getting this token without authentication is very tricky. Currently we're using LDAP queries to ask for the token group attributes on users, but this is always the view of the domain controller in relation to its own domain. So there's no SID filtering or expanding happening there. And that's why this is so tricky to get the information correctly. In most cases it's okay and it works, but it's pure luck that it's the same thing than the real authentication would give. And also with just outbound only trust, it's just not possible to ask the domain controller of another domain for this information. And the solution for this is using S4U to self, where it's possible to use the Kerberos ticket so if a computer account has a ticket for its primary domain, it can present that to the KDC and then say, please give me a ticket that looks like a ticket from user X, and that user would access me, so the service itself, and then the KDC gives the services ticket, and then the service can have a look and see the authorization data in the Kerberos ticket. Getting the S4U to self ticket in a trusted domain situation means we have to get the ticket for our own realm and then walk the trust chain and get the referral tickets and TGTs for the other realms in between, and finally for the user realm. And then we ask for the S4U to self ticket, but that still generates the referral ticket, and then we need to go the chain back to the services realm in order to get the final S4U to self ticket. And this only works with two-way trusts. So if you just have a one-way trust because you don't really trust the other side, then this doesn't work. But in a second I will explain how to solve that. Typically in the domain or forest environment, trust is forest or domain-wide. It means each principal of one trusted forest domain is allowed to authenticate to each service in the trusting forest or domain. For situations where the forest or domain belong to the same organization, that's not a problem. and the authorization is handled by ACLs to protect objects or files, and it's typically not such a huge problem. But if you want to restrict access from the outside completely, that's a bit more tricky, because in a lot of situations access for authenticated users is enough to get at least limited access. And typically one-way trusts are used to limit things. But the solution is to use selective authentication. That's a cross-organization trust I mentioned before.
Question, this is a flag that has to be put to the trust, where the trust is established.
Yes. Yeah, I mean, you can also change that later, but it's on the trust attribute value of the trust. And it's independent. You can do as you like. So you can have it selected on both sides or just on one side. And the trusting end of this trust notices that this flag is set, and then it just adds the other organization SID to the token. And with this in place, it allows the KDC of the receiving side or KDC within the forest. So it doesn't have to be or doesn't have to have access to this direct trust. It just needs to look at this other organization SID, and if that's found there, authentication firewall failed is returned. And in order to allow just specific access, you have to go to a specific service, maybe just the computer account, and then in the Active Directory ACL editor, you give the allow to authenticate to write to a group or to a specific user in order to allow access to just that service. That's a huge advantage. It's not so black and white, all or nothing like one-way trust, and it allows S4U to work properly, even without allowing principals from the other domain to access resources in the other one. In Samba we haven't implemented that yet, but we are lacking also the SID expanding and filtering. So when we implement that, it would be the time to also implement the selective authentication. Then another topic is more and more services try to avoid NTLM. And in Windows, for quite some time, there are flexible ways to do that. On the client, there is a outgoing NTLM traffic to remote servers security policy that flips the default on and off. And if it's off, you can add exceptions to that. So just allow access to specific servers which can't handle Kerberos. And when the authentication fails, it returns status not supported. For the server side, there's a similar thing, just globally blocking NTLM traffic, and also an audit policy, and also not supported is returned. For domain controllers, when they receive the some logon requests, there's a separate policy for NTLM authentication for the domain, and then also exceptions for specific servers. And that returns NTLM blocked, which is different. So when you look through, for example, Winbind logs, you would see NTLM blocked when the authentication is rejected by the domain controller. And currently, Samba returns that straight to the client, but we, in order to do the same as Windows, we should just map that to not support it in the NTLM checking code. In Samba 4.7, we changed the NTLM auth option a bit in order to be a bit more flexible. We have now NTLM 1 permitted, that's an alias to yes, and it allows NTLM v1 and NTLM v2. Then we have NTLM v2 only, that's an alias to no, and we reject NTLM v1. That's actually the default. Then the new values we got are MS-CHAP v2 and NTLM v2 only. So the MS-CHAP v2 authentication still uses the NTLM v1 hashing scheme, and that needs to be allowed for some situations. When, for example, Squid proxy or Apache web server uses NTLM auth to, or the Radius server uses that. Then we have newly added the disabled option, and that disables all NTLM and LAN authentication completely.
Where does the client indicate that it's using MS-CHAP v2? How do you know?
So when you configure the Radius server, you need to specify a specific option to NTLM auth. There's a new option to say I'm MSV-CHAP, CHAP v2, and then it passes down the flag through the NTLM messages in order to allow that. So before we just had yes and no, and the default was no, and it's effectively the same as before, but we have the flexibility for the disabling completely or the radius access. In future, we may implement a more flexible way similar to Windows, because currently this is used, it's just one option for server, domain controller, and there are no ways to just allow a specific server to still use NTLM. So, Kerberos, currently we implement mostly everything a Windows 2008 R2 domain controller would implement, and every new feature would require some development. So with Windows 2012, the KDC can use resource group compression in order to limit the size of the pack and do some compression there. And once we implement the SID expanding and filtering, we should do the same. It shouldn't be too hard. There is newly added the Kerberos fast armoring. That is important because AS request typically just encrypts the timestamp with a password, and that allows offline dictionary attacks. So when you have a domain member, the domain member would get a Kerberos ticket with its really random password, and then use a set ticket to encrypt the AS request done in behalf of the user, so that the value for the user is not seen on the network. Then there is branch-aware support, where client can say, even if it talks to read-only DC, please forward the ticket request to a read-write domain controller, or please don't forward on your own and just give me a failure if you can't handle the request. Then there is support for compound identities. So basically, when you use this fast armoring, the KDC has a chance to see the Kerberos authorization token for the computer and then also for the user, and can combine that, and the pack of the user will also have some information about the device that was used to log on. Then there's support for these claims, which can be added to Active Directory, and this allows administrators to do some access filtering based on the combination of client and server, not client and server, on the combination of device and user, so the computer and the user credentials together, in order to allow a user just to access a file when it's logged on to his workstation, but not from the laptop or so. Then there, with Windows 2012 R2, the protected user security group was added. If someone is a member of that group with the RID 525, it can only use Kerberos and only with AES keys. Kerberos delegation is not allowed there, and the TGT only has a lifetime of up to 4 hours, and credentials are never cached on a workstation.
Did you say that they can only authenticate with Kerberos?
Yes, and only if Kerberos uses AES keys. Windows 2012 R2 also introduced some authentication policies and policy silos support. I'm just mentioning it roughly here. It's something like selective authentication just within a forest, not between forests. But I haven't researched much on that yet. The same applies to Windows 2016. There's a privileged identity management where you can have features like timed group memberships. So if someone just wants to grant someone access to do something, to do some administrative task, he can add it to the administrator group or some privileged group just for a few hours or so, and then when the user logs in the next time, it doesn't have the privileges anymore. And there's also some special forest trust type in these situations, but I also didn't research all details on that yet. So, goals for Samba. What we need is a scalable, robust authentication subsystem on domain members in order to reliably serve files and let clients connect to Samba. And in the same time, we want, as an Active Directory domain controller, support for trusted domains and forests. And it turns out that the requirements for both goals are very similar. We just need to get the correct abstraction and specify the trusts with the properties I outlined before. So the trust type, direction, and the attributes. And we need to handle all specific cases there, and then we should be able to get both things, domain member and domain controller, working nicely. What we need to avoid is useless network communication. So currently, even if a client comes with Kerberos, we still need to go to the domain controller and find out if a specific SID matches to a group or a user. But currently, we have ID map backends with ID map type both support. They don't really care about the type of user or group. They just map the SID both to a UID and a GID with the same number representing the SID. So we don't have to care about user or group in the same way as Windows would do. If we have that, we should be able to avoid contacting the domain controller, but currently we don't do that, so we need to do some things there, but it should be possible. And the other thing is that when we authenticate ourselves to a domain controller, we use Kerberos, and we have a lot of redundant DNS or CLDAP requests there. We have plans to fix that and do the Kerberos network traffic on our own and just use the libraries for the crypto stuff. At the start of my talk, I had the view of the forest and the details of the forest, where we had the top level names belonging to a forest and the specific domains, and that can be used to form a routing table, and that routing table can be used to do much more efficient routing when using the Netlogon communication with domain controllers. And the key is that we only use direct trusts and never try to contact domain controllers of trusted domains without a direct trust. We just have to rely on the transitive trust to our primary domain or to other forests, and let the other domain controllers do their work. And we only should use Netlogon and LSA lookup SID or names. That are the only things Windows are using also, and we should be able to do almost everything with just that. And with the Netlogon secure channel, there isn't much more allowed. So we shouldn't use any Samba or LDAP queries because with trusted domains it can't work, and the domain controller doesn't pass them to other domain controllers for us. This routing table is already used in our Kerberos server when we are a domain controller. The client just asks its own KDC, and it's the job of the KDC to return referrals, which can be followed by the client, and the client doesn't really need to know about the routing or the topology of trusts. With NTLMSSP, we should use the routing table also in our Winbind in order to avoid contacting domain controllers of other domains where we don't have a direct trust. That would make things much more robust and reliable, even if we have just one-way trust or similar things.
The question is mainly for Winbind involving the active domain controller, because the client probably should most of the time go to our own domain controller.
Yes, so as a client we have a transitive trust to our primary domain, and so we should just use that and rely on the domain controller to forward everything as required. So another improvement was removing the map untrusted to domain option in Samba. So imagine a client comes mostly on a workstation not joined to a domain and tries to authenticate to a domain account, and we don't know about the domain part because that's the local machine's name, and that should be silently mapped to our local domain or local SAM name on the domain controller, the name of the domain, or on a member, the local machine name. In order to find out if that domain belongs to a trusted domain or not, we were using a list. So we asked Winbind to get the list of all trusted domains, and then we tried to find out if that domain we got is a trusted domain or not. This is completely unreliable because at startup Winbind didn't have the chance to contact all domains, and with one-way trust it's in some situations not possible at all to ask for the trusts. And the solution is do it the same way as Windows. We just have to pass every authentication where we are sure it's not our local name. We should just pass that to the domain controller. And if the domain controller doesn't know about it, it will just say no such user and set the authoritative flag to 0. And that means I don't know about the user, but I also don't know about the domain. And in that case, the workstation should just map that to the local SAM name. And for Samba 4.7 we have changed the option to have a new default, a new behavior with auto. So we just exactly do that and pass everything through the domain controller. And in future versions 4.8 or so we will remove that option completely and keep that behavior. So the other thing was, for the domain controller, we need a fully asynchronous authentication stack in order to do authentication without blocking when we wait for other domain controllers. And we had the semi-async gensec update EV function, which takes an event context which is already running, and we would then just loop the event loop again, and that is very bad. It was possible to have that, as we didn't have support for trust as ADDC, but now we try to add trust support. It's not possible to have that. So we had to remove that, and for some situations it was easy, where we just accepted Kerberos, and there we can just use the Asynchronous version, just gensec update, that is just blocking, and we have gensec update send and receive, which then integrates nicely with our T-event library and doesn't block the server while doing the authentication. I was able to change some of this, and the rest needed to use the full asynchronous function calls. And the hardest part was rewriting our SPNego implementation, which needs to try one mechanism, then find out it doesn't work, and then recover and retry, all in asynchronous way. And it took me 82 patches to untangle the strange logic we had there and make it completely asynchronous. Then I added support for NTLM authentication and also added support for asynchronous password checking there, and the Winbind implementation for authentication, which then talks to Winbind and lets Winbind talk to other domain controllers that makes use of it. And we have now support for trusted domains with NTLM, and that will be Samba 4.8, I guess. It didn't make it in 4.7. And we now just use this hard-coded list of auth methods. First we try anonymous, then we try our local SAM, then we ask the domain controller via Winbind. And if we're still not in a situation where the domain controller said, I know the domain, but the user isn't there, then we map things to our local domain again, and so to the local SAM. So the next steps are making sure, because the trust support for Active Directory is new, we should, in this situation, just avoid some R and LDAP access for trusted domains in Winbind, so that we don't have the situation we have as the main member now, where customers rely on that and we are not able to get rid of it again. Then we need to use the S4U to self code in Winbind. Maybe we should try to use this fast for Kerberos in Winbind when we do PAM Winbind authentication with Kerberos. LSA lookup sits and names need support for trust, and delegate worked Winbind. Winbind needs a trust routing table. Then we need, for Active Directory, automatic creation for foreign security principals that's needed in order to allow group memberships from other domains to be part of the local domain. Then the SID expanding and filtering, the selective authentication implementation. Then I'm basically done with my talk. There are some future or some things to check for the future, where we have some things like GSS proxy, so decoupling authentication and delegate it to the proxy process on a box. That could be Winbind. Constraint delegation with S4U to proxy. So when you have a proxy server, the client comes, authenticates against you, and you should then connect on behalf of the user to another service that's used for that. Then there's some further security hardening, channel bindings for LDAP connections with TLS or HTTP connections, and some service principal target name validation. Then there's also this public key cryptography based user-to-user authentication. Matthew George mentioned that yesterday in his talk. So this PKU2U is then used to replace NTLM in a scenario where you don't have a domain, and then basically the target server acts as a KDC, and the GSS API traffic then wraps the AS request in order to get a ticket and then do the normal Kerberos authentication. Then there are managed service accounts, just as a topic, and then we are at the end. Do you have any questions? Michael?
I have one question. So the selective authentication, am I correct in assuming that it requires implementation both in server and client, or only in server?
Only server.
So that is for members, the shell access establishment, they take advantage of already. Repeat the question, please.
The question is, does the selective authentication need to be implemented on a domain member and the domain controller? And the answer is just on the domain controller. It's transparent to the domain members. And Steve?
Yeah, I was looking at larger customer traces and noticing a lot of this, the traffic you're talking about with talking to the trusted domains. Is there a way to easily in Winbind verify whether it's a one-way or two-way trust between the domain controller and the other domains?
No, you need to have a look at the domain controller.
Okay.
And then there are quite some useful links here at the end of my slides. So if you get them, you can check as you want. So thank you.